This video is going to be a review of exponent rules. You should have learned about exponents in Algebra 1, and this is going to be a review. We're going to go over, try to touch on all of the basic rules that we would need to know for Algebra 2. First of all, when we have exponents, you should remember that the big number is called the base, and the exponent is the little number that's raised up there. And that exponent tells you how many times you should multiply it out. So if it's a to the nth power, that means you need to take a and multiply it out n number of times. Now, what we mean by the base is what is being multiplied repeatedly. So whatever it is to the power is the base. So in other words, if I have negative 2x to the fourth power, my base is just the x. It's not the 2, it's not the negative, it's just the x in this case. So that means we have a negative 2 times x times x times x times x. And that comes out to be negative 2x to the fourth power. Now, if we rewrite it so that we have parentheses, in this case, our base is 2x. And so 2x is what's getting multiplied over and over and over. But again, notice the negative is not part of that. So the negative is going to be outside, and then we have 2x times 2x times 2x times 2x. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So multiply all those 2's together and you get a 16. You still have the negative, so you need that negative there. And then, of course, it's x to the fourth. And for our last example in this section, if you include the negative in the parentheses with all of that, then that means that negative 2x is your base. And that means you're multiplying a negative 2x times negative 2x times negative 2x times negative 2x. And that comes out to be a positive 16x to the fourth. And it is positive because a negative times negative is a positive, times another one is a negative, times another one, you're back to positive again. And so that's why it comes out to be positive 16x to the fourth. Now, of course, you don't have to write that positive sign in there. I was just doing that to clarify because that's what we're talking about, is how to do this. So I just had that to clarify. Properties of exponents. I'm curious how many of these you actually remember. So I'm going to go through the first example with you to kind of show you what I want in this section. And then I'm going to give you some time to fill in the ones that we don't go over together. So x to the third times x to the second, I'm going to go in and show you everything I'm multiplying out. X to the third is, of course, x times x times x. X to the second is, of course, x times x. And so all together, we have 5 of them. And so our answer here is x to the fifth. And so over here in the rule, I'm saying when I have that situation, I added 3 plus 2 to get 5. And so my general rule is I'm going to add those together to get whatever answer it is. Now, I do want you to make sure that you're not just memorizing the rules, but you actually know what each of those rules is. And so for each of the next examples in this table, I want you to go ahead and write out the expanded form, and then give the answer, and lastly give the rule. Because again, I do not want you to just memorize them. I really want you to understand what each of them means. So take a minute to pause it here and go through the rest of this table and see what you can come up with. So one thing is I went ahead and wrote that in the margin. So you might take a minute to write that out, that you do not just memorize these rules, understand them. Because I see a lot of students trying to just do this through memorization, and that gets them into trouble later when they have to really know what's going on and they're not sure why something is working out. So I really like to always go back to writing it out the long way. Once you've written it out the long way, you understand the rule, that's fine. You don't have to write it out every time. But I'm going to show it here, writing it out, so that you really understand why the rules are what they are. The next example is a power of a power. And by a power of a power, I mean if we have x to the third and you take that to the second power, that means we're going to have 3 x's multiplied together times 3 more x's multiplied together, because it's multiplied times itself. And so in total, we have a total of 6 x's here. And so our answer on the rule is when you have that situation of a power, you multiply m times n. The next one says a power of a product. So we have a power, that means we're taking xy times xy times xy 3 times because it's to the third power. I can rearrange that. Multiplication is commutative. That means I can move things around. So I can move things around and I can say, well, instead of saying it that way, I'm going to say it x times x times x times y times y times y. And so that is obviously x to the third, y to the third. I'm reluctant to call it distribution, but I'm going to say that word because I think you'll understand it. But it's not exactly like distribution that we've had in the past. It's similar though. That is, if we have an m on the outside, we basically distribute that to the a and the b. They both receive that m. Now, I'm reluctant to say that, but if you understand these rules and how they work, then that rule is going to make sense. Okay, let's go to the next example. Negative exponents. First of all, in the margin, make sure you write this down. A negative exponent does not mean a negative number. It means reciprocal, and that is completely different. And so in other words, if I have 2 to the negative third power, now I'm going to run out of space, so I'll do the best I can here. But if I have 2 to the negative power, that's like 1 over 2 to the third power, which is 1 over 8. And if we have 1 over 3 to the negative second, once again, we have to do the reciprocal. So we're going to put 3 to the second on top and put the 1 on the bottom. And so then 3 to the second, well, 3 to the second is just 9, so that just simplifies down to 9. And the rule is that a to the negative nth power is 1 over a to the nth. Okay, let's look at our quotient of powers. X to the 7th over x to the 2nd. So we have 7 x's over 2 x's. Well, if we have 2 in the denominator, we can cancel those out with 2 in the numerator, and that leaves us with 5. So this answer is x to the 5th. And the shortcut then to that would just be to subtract m minus n. So there was 7 minus 2 is 5. And so if you have, but that has to have the same base. They all are x's here. I didn't have a y, I didn't have a z, I only had the x's. And so they have to have the same base in order to subtract those powers. And the power of a quotient, 3/4 to the second power is just 3/4 times 3/4. And when we multiply these together, we multiply straight across, and that gives us 9 over 16. Now I've kind of scrunched this one in here, so it's kind of hard to see, but this is 3/4 to the negative second power. Well, if it's a negative second power, we have to do the reciprocal. And so we do the reciprocal of it, and that gives us 4 over 3. And then we take 4 over 3 and take that to the second power, and we get 16 over 9. Once again, we can use that term distributive. Again, I'm kind of reluctant with that term because it means a lot of different things, but in this case, what it means is I'm going to take a to the nth m power over b to the m power, and I'm going to get my answer. So here it was 3 to the second, that's 9, 4 to the second, that's 16. And so you just take that power onto both the numerator and the denominator. And our last rule is the zero exponent rule. Basically, anything to the 0 power is 1. So it doesn't even matter what all is in here. If you take it to the 0 power, the answer is 1. Now again, we have to think about that base because let's write in another example here. Let's say you had something like, I'll just use this example, 296 times x to the 0 power. Well, that would be 296 times 1, and so that's still 296. And so again, you just have to look at what the base is. In this case, it had the parentheses, and all of that was inside of a parentheses, so all of that became 1. But if the 0 is only on one of those terms, then only that one becomes 1, and you still have the 296 or whatever the numbers you have. One more basic concept I want to take a look at before we do some more examples is the concept of scientific notation. I'm surprised at how many people don't know how to use their calculator for this. So that's one thing I'm going to have you do is take out your calculator. So go ahead and take out your calculator. The thing you need to remember is that you really want to rearrange this because multiplication is commutative. Again, we can move things around. So if it's written out like this, well, that's great, but we can move things around. And what we want to do is we want to multiply the numbers, the 8.45 times the 6.72. Those numbers I there's different sources that call them different things. Some sources call those coefficients. Some call them something called significans, various names. But basically, we're just looking at the decimal numbers. We're taking the two decimal numbers and multiplying them together. And so if we go to our calculator, and we multiply 8.45 times 6.72, we get the answer 56.784. So I'm going to go back to my paper, and I'm going to write that in. So that is 56.784 times 10 to the, well, again, we're doing a multiplication here. And so as we multiply that, I've got a misprint here. This should be 10 to the 9th, not 10 to the 7th. Let's change that to a 9. So if I multiply those two together, that's going to give me 10 to the 14th. And so my answer is 56.784 times 10 to the 14th. However, as you may know about scientific notation, you really only want a ones place. You don't want a tens place with this. So we need to move the decimal over one more place. And if we move it over to the left like that, that means we need to add another exponent in our order of magnitude, in our 15 there. And so this comes out to be 56.784 times 10 to the 15th. Why don't you take a second with your calculator and try to figure out this problem. Again, just use your calculator to multiply the two decimal type numbers together and then do your exponents after that. Okay, when you multiply that out, you should get 1.7897 times 10 to the 4th. Okay, let's turn the page, and on the other page, next page, we've got a bunch of examples that we're going to work through. I don't think it'll take us too long to do, but I want to show you, because all these in the table we have are just like one example of like one isolated case, but of course, when we get onto homework, we're going to put all those together. And so we want to see what it looks like when we put everything together. Okay, so here's an example, for instance, number 1, or letter A. I've got all of these things going on. How am I supposed to do that? I think makes it much easier on yourself if you regroup things and put the like items together. So like put all the numbers together, put all the x's together, put all the y's together, put all the z's together. And then you just have to simplify each one. And so now that I have them regrouped, now it's very easy to see that this is going to be 8, and this is going to be x to the 5th, that's going to be y to the 2nd, and that's going to be z to the 10th. So if you regroup them, it helps you come up with your final answer. Now, you don't have to physically rewrite it out every time. Again, I'm doing that in the notes here because I want to show you how it's done. But if you just jump straight to this answer, that's okay as long as you know what you're doing. You just have to keep things straight. This next one, again, it's quite complex, and so we can look at it two different ways. Since it's to the 3rd power, we can take everything in parentheses, times itself 3 times, or we can kind of distribute like we've talked about. That we'll take -2 to the 3rd, x to the -1st to the 3rd, and y to the 2nd to the 3rd. So whichever way you want to do that, but what that's going to come out to is a -8, x to the -3rd, and y to the 6th. Now, with negative powers, we do not want to leave negative powers in our answer. And so since that means reciprocal, that means it has to go to the denominator. So x to the 3rd has to go to the denominator, but y to the 6th stays up there in the numerator. And it is a -8. That negative can go just outside the fraction bar, or it can go on the -8, however you want to write that. But -8 y to the 6th over x to the 3rd is our final answer on that one. Take a minute to look at these next two and see what you come up with. Hopefully on this one, part C, that was an easy one. Anything to the 0 power is 1. Now, example D, again, I want to take that concept of grouping like items together, and I want to look at this as kind of two separate pieces, because 12 over 2, that simplifies down to 6, and m to the 6th over n to the 3rd, we subtract that, and we get m to the 3rd. Okay, example A here. Again, these are just more examples, but everything on the numerator simplifies to 1, but that only applies to the numerator. It does not apply to the denominator. The denominator, there's not really anything we can do. It's just 2ab. This next one, again, you can think of it as distributing that second power, or you can think of it as times itself twice. But that's going to give me a 16 x to the 6th over 4. And then I need to simplify that. So the way I do that is my 16 and 4 reduce down to just a 4x to the 6th. All right, part C, or question C here, I'm going to distribute that 3, but then I still have my xy. So in other words, I'm going to have x to the 6th, y to the 3rd, but I still have my x and y. And so now my final answer is x to the 7th, y to the 4th, because x to the 6th times x is x to the 7th, and y to the 3rd times y is y to the 4th. On example D, what you want to do with fractions is you want to multiply straight across. So I would go ahead and write that out in the margin. With fractions, you want to multiply straight across, and then after you've done that, then you cancel or simplify. So if I look at example D, what I'm going to do is I'm going to do my numerator straight across. That's going to give me a to the 4th, b to the 2nd, and c. In the denominator, I have b times c. Now that I've done that, now I can reduce these or cancel them or simplify them. And some people like to do the simplifying first. That's fine, but I just think to keep things straight, it's a little bit more organized if you multiply straight across first. So now this c and this c cancel each other out. This b, one of these cancels with this one. And so our final answer is a to the 4th b, and that's it. Example E, when we have a power of a power, we multiply. So that's a negative 16th power. But of course, a negative power means 1 over. And so we have our answer like this. Again, notice there's no negative in my answer. I never leave a negative exponent in my answer. Okay, example F looks really confusing. Why don't you take a minute to see what you can do with it? I might give you a hint as to starting, and what I would do to start it is I would flip it over to start with. And when I say flip it over, I'm talking about the reciprocal, because there's a negative second power here. So what I can do is I can flip that over and then put a second power on it instead of a negative second power. Okay, now that I've gone that far, why don't you see what you can do? Multiply, simplify, cancel, whatever you need to do to get down to the lowest answer. Okay, your final answer should be 9 over 4x to the 4th, y to the 4th. A couple things. The z remains a z to the 0 because 0 times 2 is still 0, and anything to the 0 power is just 1, so we don't need to write it into our answer because it doesn't add anything to the answer. So we're just going to leave that z to the 0, leave that as 1 and leave it out. The x's, that's the other part where people have a hard time. We have x to the negative 6th and x to the negative 2nd. Well, if you take a look down here, I'm going to explain how I came up with x to the 4th being in the denominator. What I did, and there's several approaches, but what I did is I knew that if they're over each other like this, it means subtract. So we have a negative 6 minus negative 2. And negative 6 minus negative 2 is like negative 6 plus 2, which is x to the negative 4th. And then, because it's a negative 4th power, I know that that means 1 over x to the 4th. So that's how the x to the 4th went into the denominator. Now again, there are lots of different ways you can go about explaining that. Some people, because they're both negative, they want to flip it. You could do that too. You could put x to the 2nd on top and x to the 6th on the bottom, because negative moves, so you get x to the 2nd over x to the 6th. Again, you subtract those and you get 1 over x to the 4th. However you want to do that is fine, as long as you make sure you're following all the rules accurately and you come up with the right answer. So that is the final answer on example F. Unfortunately, I did not leave space for a summary here. So therefore, I'm not going to make you write a summary, but you might take a minute to remember what some of the rules are. It really helps your brain to remember things when you write that down. So you might take a minute to write that down. Just list out what are some of the rules, how do you remember them, maybe just take a minute right now to look over the table, and that table has all of the basic rules, but the other side of the paper has all of them put together. Okay, that is our review of exponents. We will continue to work on those in class, and we're really going to use them in other contexts. We're not going to have a whole lot of just basic exponents because I'm assuming you've learned this before.